All right, so hopefully you got through that first video. You chose your two problems, you've checked in with Mr. Magel, and now you're moving on to the next video. So I'm back on page 8, and what we're going to talk about now in this section is if it is in standard form, how to get it into factored form. And this is I'm showing you in green is one of the most important things you have to learn. You have to be able to factor successfully in Algebra 2. So this is not one to blow off. You learn this one way in Algebra 1, and I'm going to be showing you a different way in Algebra 2. It's a little bit faster, and I know we all like a little bit faster there. So hopefully this makes sense. So before we do that, let's just talk about how do you factor a polynomial. Again, I'm back on page 8. So the first thing you're going to always want to do is factor out a GCF, which stands for greatest common factor. After that, you're going to see how many terms you have. 2 terms, 3 terms, and in a later chapter, 4 terms. And terms are those pieces that are separated by addition, subtraction. So in standard form, ax squared is a term, bx is a term, and c is a term because they're separated by addition, subtraction. And if I go to page 9, x squared is a term, 8x is a term, 15 is a term. So if you have 2 terms, we're going to use to factor, if it's possible, what's known as a difference of squares. There is the more formal definition of it, and it just says this. And I'll explain it to you with an example instead. So we're going to choose x squared minus 25. The reason this gets named difference of squares is because there's difference, that's a subtraction, and the 2 terms that we have perfect square roots. They are nice and simple, no decimals. So what you do is you take those square roots. So the square root of 25 is 5, the square root of x squared is x, and then from there you will be putting it into factored form, which means we need 2 factors. And factors multiply to give you what you started with. So I'll take these and I'll put them in here, and I'll have one with an addition sign and one with the subtraction sign. So if I have this neighbor meet this neighbor, I'll get x squared, I'll get a negative 5x, and then a positive 5x, which will cancel each other out. And then when these neighbors meet, I'll get the minus 25. So we're basically just undoing the neighbors meeting the neighbors. So back to this formal definition, you would take the square root of a squared, which is a, you would take the square root of b squared, which is b, and you would do a plus b, a minus b. And it's so simple. This is like the easiest factoring you could ever do. But the simplest things do become the toughest things in the end because we think we have to do more. So the other way you factor is what we call the X method. And the best way to show you that is doing the examples on the other side. So I'm going to flip to page 9. And from standard form to factored form, you need to factor. The other thing you need to make sure of is that it is in standard form before you factor. And standard form just means that your highest powered term is first, the x squared, then the x term, and then just the plain number. Okay, so x squared, x number, x squared, x number, x cubed, x squared, x, and then there's no number here. So the first thing I'm going to do for every problem is ask myself, is there a greatest common factor? Is there something I can divide or factor out of all 3 things? And now what you're going to need with you is, hold on one second, I'm getting there, is this green factor page that you would have picked up at the beginning of class. So again, just a reminder what factors are. Factors multiply and they give you a number. So for instance, factors of 6, 1 and 6, 2 and 3. Because when I multiply them, I get back to 6. So 2 is a factor and 3 is a factor, for instance. All right. So first you make your x. It is in standard form. There is not something I can factor out of all 3 terms or divide out. And what you do is we're going to fill out the x. And if it's in standard form, you will draw a loop and you multiply those, and that goes in the top part of your x. and then the middle term goes in the bottom part of the x. And what we want to do is find factors of 15, so I'm going to use my green page, that if I add or subtract will get me to 8. And most of you are probably really great with factors, but just in case you aren't, which of these will get me to 8 if I add or subtract? And that will be the 3 and the 5. And when I put the 3 and the 5 in, I will put the x's. And it doesn't matter if you put the 3 or the 5 first, but what happens is if you multiply 3x and 5x, you get 15x squared. And then if you add these, you get the 8x. And it's really important that all of these have an x in them for when we get to factoring with higher powers, not just with something squared. So from there, we're actually going to go straight into our parentheses. So again, we are undoing the neighbors meet the neighbors. We are going to see who are the neighbors that met, that got us there. And so when this neighbor goes to meet this neighbor, we get the x squared. So what times what gave us x squared? And that's how we're going to fill this in, x times x. And then from there, I'm going to let these numbers help me get the other parts to it, who the other neighbors are. So what happens is I'm going to x meaning that neighbor, so somebody not in the same house, and x meaning that neighbor. And I'm going to ask myself, can I take x times something to get to 3x? And I can, and that's 3. So I'm going to put plus 3 because it's a positive 3. So that takes care of my 3x. And then I'm going to ask myself, x times what could give me 5x? And that would be a 5, so I'm going to put plus 5 because it's a positive 5. And now I factored. When this neighbor meets this neighbor, you will get back to this. You get x squared, you get 3x and 5x, which make the 8x when you combine them, and then you get 15. So let's go to the second one. The first thing I'm going to look for is a GCF. Always look for the GCF. So out of all of these, I can factor a 2 out, and then when I factor or divide a 2 out, I get x squared left. Divide that by 2, I get 8x, and divide that by 2, and I get 15. So of our factors, we have found one of them, okay? What we're going to factor now is this part, and this is what's going to help me make my x. So again, I would take this times this, I get 15x squared. This would go in the bottom, 8x. And again, I would look for factors of 15 that get me to 8. And some of you might be realizing, wait a second, we just did that, so it's going to be 3x and 5x. And so now I'm not going to redo this whole thing. But, well, no, I will. So you're like, oh man, Miss Lawson, what are you doing? So joining the 2 in the factors will come these. And again, what times what can get me this x squared? What neighbor to get x squared? It's just x and x. So from there, I'm going to do my little connection. And for instance, you know, I started from x times what can get me to 3x. I could do this one. X times what can get me to 3x, and I could put the plus 3 in here and get my 3x. And then I would have to do the x times this one to get my 5x, and I could put the plus 5 in here. So, you know, you're not set a certain way all the time. All right, let's go to the next one. So the first thing I'm going to look for is a GCF. Is there something I can divide or factor out of all 3? I can't. So I'm going to make my x. I'm going to multiply those. That's 21. X squared, and then the 22 is going to go on the bottom. Note all the x's that are in there. And now I need factors of 21. I'm going to use my green page. That helps, whether I add or subtract them, get me to 22. And it's going to be the 1 and 21. So I'm going to put 1x and 21x, and it doesn't matter if you put the 21x first and then the 1x here. So now I'm going to make my parentheses. I'm going to go straight into this. So again, I want to know who met who to get this 3x squared. And we're not going to have any crazy fractions. It's going to be simple. It's just going to be a 3x and an x. And now I'm going to let this help me decide who the other people are that met. So I'm going to draw my loops, and I'm going to fill this in. So can I take 3x times something to get to 1x? No, so I won't use that one. But I can take 3x times something to get to 21x, and that's going to be 7. So my 21x is taken care of. So that means I'm going to use x times this one to get to 1x, and that's going to be a 1. Never put 0 in there, all right? Because if 0 is a neighbor, multiplying by 0 makes everything disappear. So that one's the answer. I could box these in. Here's the answer. Here's the answer. So let's try to get through the other three before my bell rings. So here when I go for my GCF, this time I can't factor or divide out a number, but I notice every term has an x, so I'm going to divide or factor out an x. So basically, instead of having 3 x's here, I'm going to have x squared. This will be 3x, and this will just be minus 9. And now there's one of my factors that will be part of my answer, but this is what I'm working on factoring now. So I'm going to make my x, and I'm going to get negative 18 x squared, and the bottom will be the 3x. And now I'm going to look at factors of 18 that if I add or subtract them get me to 3. So the only set that can get me to 3 will be 3x and 6x. And right now if I add these I get 9, and I need to get 3, and if I multiply these I get 18x squared, not negative 18x squared. So I'm going to have to make this negative, because the negative and the positive make the negative here, but when I add these, I still have a positive 3x. So, joining the x, here come my other factors, here come my other neighbors. So again, who met whom, I don't know, to get me 2x squared. So it's just going to be 2x and x. No fractions, just simple numbers. And now, who did 2x meet, and who did x meet to get this? So first I'm going to ask myself, can I take 2x times something to get to negative 3? And I can't. But I can take 2x times something to get to 6x, and that would be 3, so I'm going to put plus 3. So my 6x is taken care of. That means I'll have to take x times something to get to negative 3x, and that'll be a negative 3, so I'm going to put minus 3. And now I have all my neighbors. I have 3 neighbors. This, and this. I have 3 factors, x, 2x minus 3, and x plus 3, and now this is factored. So the bottom two, you're going to notice, only have 2 terms. So remember, with 2 terms, we want to check for that difference of squares, that there is subtraction between them, which there are, and that each term has a nice square root. So before I do that, is there a GCF? There's not. There's subtraction. This has a nice square root. This has a nice square root. It's x and 4. So I can go straight into my factors or into my neighbors, and it will be x plus 4 and x minus 4. And now that one's factored. 6, again, subtraction, 2 terms. This has a nice square root of 3x. This has a nice square root of 8. And I can do 3x. This time I'll put the minus first. It doesn't have to be the plus. And 3x plus 8. All right. This video is almost done. You are now going to be moving back to the practice, page 12, and I think for this one, why don't we do, we're going to do one more together because this question popped up in B, and I would like you to pick 3 more problems. So when you're done, there will be a total of 4 completed. We'll have done 1, you'll do the other 3. So this problem, because this was asked about in the red group, first there's not a GCF. And don't worry that these equal something now. That's just to get us set up for later. And I'm going to make my x. There's 30 x squared. And then the bottom is down here. And now I'm going to ask myself, what are the factors of 30? That'll get me to 31, and that'll just be 1 and 30. So I'm going to put 1x and 30x, and the bell might ring here, so just hold on. All right, so going straight to my neighbors or my parentheses, I need to ask myself, who met who to give me 6x squared? And what we realized in one class is that it could have been 2x and 3x that met, but it also could have been 6x and 1x, but only one of these is going to work. So this one's going to be a trial and error. So let's try the 2 and the 3, trying to get these numbers. So can I take 2x times something to get to 1x? I sure can. I can, oh no, I can't, sorry. Can I take 2x times something to get to 30x? And I could. That could be a 15. So if the 30x is taken care of, then I want to see, how do I get the 1x? So can I take 3x times something to get to 1x? And I can't. So this one is not going to be our route. It'll be this one. So can I take 6x times something to get to 1x? No. But I can take 6x times something to get to 30x, and that would be a 5. So I put plus 5. So there's my 30x taken care of, which means I'll have to take 1x times something to get to 1x. And you always need a number. It can't be 0, so I'll put a 1. because 1x times 1 is that 1x. And now this one is factored. So there's 1, you do 3 more, and then you're going to check in with Mr. Magel before you move on to your next video.